All right. Afternoon, ladies and gentlemen. Hopefully you are keeping up with your studies. All right. So this is day 2, numbers 6 through 10 for polynomials. Okay. So this is number 6. So I'm going to scroll in here. All right. So that's the best we can do, right? There we go. So, hopefully that's not bugging you too much. Kind of bugs me. There we go. All right, so when x times x minus 5 times 2x plus 3 is expressed as a polynomial in standard form, which statement about the resulting polynomial is true? Okay. So, it might seem like a lot of work at first, but it's really not. Okay, but what we're going to have to do is we're going to have to multiply this x into both of those. We're going to get a whole new expression, and then we're going to multiply that new expression with that third one. Okay? So don't get nervous. It's not too bad. Okay? It's not a whole lot of work, but it is work. Let's make it a different color here. So you're going to take that x, and we're going to multiply it into the parentheses here, the distributive property. All right, if you guys just got done with that last video. All right, so we distribute that x. We get x squared minus 5x. Okay, don't forget, when you multiply stuff that has the same base, okay, you have to add the exponents. In this case, it's 1 plus 1, which is 2. All right, so here's our new expression. And now we're going to multiply it into that expression. Okay, so here's my arrows again. Okay, we used to call this FOIL back in the day. Apparently they don't like that name, which is weird because we're still doing the same process. I'm just complaining. But anyway, so we're going to get x squared times 2x. And that'll give us 2x cubed. Okay? Because we got this 2 and we're adding it with this 1 there. All right, don't forget we have the same base. Okay, so we multiply the 2 and that invisible 1 in front of that x squared, so we get 2 times 1 is 2. And then x squared times x is x to the third. Okay? Whoops, I'm going to do that. All right, so now x squared times 3 is 3x squared. Now we're going to go negative 5x times 2x, which is negative 10x squared. And negative 5x plus 3 is negative 15x. And I'm missing just one piece. Don't forget to combine like terms. When you combine like terms, whoa, how about I do it there, mister? Okay, so plus 3 and a negative 10 will give me a negative 7 x squared minus 15x. Okay, so that is our answer when we express this polynomial in standard form. Okay, also you're like, what's standard form? Okay, what's nice about this is it already kind of set it up for us just by the way we're multiplying. But standard form, all right, is where we list our terms in, succession here based off of highest degree measure. Okay, so let's talk about that real quick. Our degree measure here, for this first one, don't forget we're just looking at this number right here. All right. Remember, constants don't have a degree measure, so if we just had a 2 there, your degree measure is 0. Okay? We have a 3 for an exponent there, so our degree measure is 3. On that second term, our degree measure is 2, and on our third term, our degree measure is 1. Okay, we haven't encountered any problems like that, or like this, but just keep a heads up. Okay, when you have something like this. So let's just talk about these right here. Okay, these are all just separate pieces, right? So if I want to talk about their degree measure, I would say 3x has a degree measure of 1. Okay, 5x squared has a degree measure of 2, and 2x to the 4th has a degree measure of 4. Okay, so which one has the highest degree measure? This one right here. Now, I'm going to talk about these. Okay, now let's talk about these 3 separate monomials. All right, so the degree measure of this first one, all right, is actually 4. Okay, because what you're looking at is we have actually 2 different variables there, right? And so all you do is you just kind of add up their exponents. Okay, so in this case right here, 3 plus 1 is 4. This one we just still have a 3 there. So our degree measure is 3. And this one we have a 2 and a 4, so its degree measure is 6. So just be careful when you run into problems like these, right? These ones are a little more obvious as far as degree measure because you're just looking at one variable. When you're looking at 2, you must make sure you add up all the exponents. And even like this first one here, okay, you don't see a number here, but you got to remember that there is that 1 there, okay? So just a little extra lesson there for you, but in case you encounter a problem like that, you'll be a little more equipped for it. Okay, so anyway, this is in standard form because our terms are listed, okay, from our highest degree measure to our lowest. Okay, so that's what it means to be in standard form. Now, let's take a look at some of these answers. So it says, when blank is expressed in standard form, okay, I'm not going to read that whole thing, but yes, polynomial is in standard form. Which statement about the resulting polynomial is true? Okay, so let's just go through these and kind of pick out which ones are wrong. Okay, that would be the easiest that'd be the easiest method first. So I'm looking at this first one here. The constant term is 2. Okay, when we're talking about a constant term, we're talking about a number that is just by itself. Okay, it doesn't have an x with it. So if we had something written like this, our constant term would be 5, right? Because we don't have an x located by it. But in all of our numbers here, as you can see, we have an x listed next to all of our numbers. So therefore, we don't have a constant term. So this one is out. And I'm also looking at that number 3 there. Okay, that one's been standing out to me as well. So the degree of our polynomial is 2. That's what it's saying. The degree of the polynomial is 2. All right, so how you determine the degree of your polynomial? Well, you need to look at the highest degree you see amongst your monomials. All right, and if you look, okay, remember our degree measure was 3, this was 2, this was 1. All right, so what's our highest degree? 3, so the degree of this polynomial is 3. And so, therefore, we know that this one has to be wrong. And then I just go right to the one below it because that one just stands out even further. All right, it says the number of terms is 2. Okay, so they're saying we have 2 terms here, and that is clearly wrong because this is a trinomial. We have 1, 2, 3 terms. Okay, so therefore, this one is also out. So the only one we have left is number 2. It says the leading coefficient. Okay, so boy, this is a good problem here because we're kind of introducing all sorts of stuff that you guys are going to need through the rest of this chapter. So when we say the leading coefficient, what we're talking about, okay, is when you have a polynomial expressed in standard form, right, we're talking about the number that comes in the front. Okay, now it has to be in standard form. If you had it written like this, okay, and said your leading coefficient is -7, okay, you were wrong. Okay, because it's not in standard form. This needs to be in the front, right? And when it is written in standard form, all right, then you just look at that first number. Okay, and our first number is 2, so our leading coefficient is 2. Okay, and it has to be that answer because we pretty much eliminated all the other ones. And that's the only one that makes sense. All right. Let's go down to this one right here. So it says, which expression is not equivalent to 2x squared plus 10x plus 12x? Okay. So, there's a couple methods you could do for this, right? I'll teach you the long way first, and then I'll teach you the easy way. Not the long way, just the shortcut way, if you will. Right? It's not any super long, but in case it says solve this algebraically, you never know. You need to make sure you can do that. So it says which expression is not equivalent to this expression right here. So we need to look at all 4 of these, and we need to decide which one of these is not equal to this one at the top. Okay? All right. Now, one method that you could do, I guess this is a third, is you could multiply all these out. Okay? You can multiply all these out here. All right? I think that would take, well, equally long as this route, but that is one method. Okay? Multiply all these numbers out here. Okay? If you multiply all 4 of these, okay, do your arrows, you would find that one of these is not equal to this one over here. So that's one route you can do. In fact, well, let's do that. All right, let's do all 3. I got time. I'm not doing anything. All right, so we're going to start with this one right here. 2x plus 4, x plus 3. Whoops. All right, so we're going to get 2x squared plus 6x plus 4x plus 12. Combine like terms. Is that the same as that one up top? Sure is. All right, so this one's out. Let's try this one. All right, let's do our arrows. All right, and again you get 2x squared plus 4x plus 10x plus 12. Combine like terms. Oops. Should be 6x. I'm getting ahead of the game here. Plus 10x plus 12. All right, so again, that's the same one up top there, so that one's out. All right, let's try this one here. So I'm going to go 2 times x plus 3, x plus 2. So I'm going to multiply that 2 first. All right, so you're going to get 2 x plus 6 times x plus 2. Do my arrows again. So now I'm looking at 2x squared plus 4x plus 6x plus 12. Combine like terms. Again, I'm getting the same thing as I am up there. So it has to be this one, all right? And I'm going to do that one only because I like torturing you. And also, just to prove to you that that one is the wrong one. So when you multiply this out, okay, you get 2x squared. Your outers, your plus 4x plus 3x plus 12. So when you combine like terms, what's happening is you're getting 7x in the middle instead of 10x. Okay, so this one is not equivalent to the big one. And I guess that's probably the easiest route. The other route you could go, all right, is you could factor factor this, you're going to have to take out a GCF. Okay, so when you factor this expression here, okay, when you take out your GCF, what you're looking for is the number that can be divided, that can divide into all three numbers, which in this case is 2. So you don't want to divide it out, you just factor it. So you just take it out in front. You're left with this. And then in order to factor this, we need to look at the factors of 6 first, which is 2 and 3, and 1 and 6. And because we have a plus and a plus here, that means that both of the numbers have to be positive, and they both have to multiply to 6, which that's what we got the factors of 6 for, and they have to add up to 5, which in this case is only 1, which is the 2 and the 3. So you get 2, x plus 2, x plus 3. And again, if you scroll up there, you look, you'll see you have that one right there. So you cross that one out. And then really all they did was they either distributed the 2 into this set of parentheses, which would cross out this one, or they distributed the 2 into this set of parentheses, okay, in which case that one get crossed off, okay? So that was a couple ways you could solve that one. All right, moving on here. Those of you that are still with me, cool. So the length of a rectangular patio is 7 feet more than its width. The area of the patio, which could be represented by this, right, that's our output. Y values, I guess, okay? Can be so our output can be represented by this function. All right. So let's talk about what it means to find the area of the rectangle. I know you guys are jealous of that nice rectangle I just drew there. Okay. So let's talk about it. So how do you find the area of a rectangle? Length times width, right? Or base times height. Right? That'll give you your area of a two-dimensional shape or a two-dimensional rectangle. All right, so the length of the rectangular patio, right, is 7 more than its width. Okay, so let's say our width is x. Actually, oh crap. All right, well, because we don't want to do that because our answer is in W, isn't it? So we just want to leave it as W. Okay, but our length, it says, is 7 feet more than its width, which means our length is equal to the width plus 7. So I'm going to use substitution. Okay, and for L, I'm going to substitute this expression in. W plus 7. And now in order to find the area of a rectangle, we're going to multiply the W. Whoops, it's bad looking W. So it's length times width. In this case, width times, W times W plus 7. All right, in this case, we just distribute the W. And so actually, let me make it look a little more familiar with what you guys usually see here. Right, the width times W. So distribute that through, you're going to get W squared plus 7W. And so go up to your options. Do we see that? We sure do. Option number 2. Okay. And that's how you solve number 8. Number 9. Oh, okay. We've got another equivalent problem. All right. So, our best way to go about this is, well, just going to have to do it the long way. There's really no other nice way to do it. Okay, so we're going to have to distribute that 3 we're going to have to distribute that negative 4. All right, so we're going to have 3x squared. Actually, let me write it over here so it has more space. So come on, let's use that white space. Change colors here too. I'm going to go green. So we're going to go 3x squared plus 6x minus 9 minus 16x squared plus 28x minus 20. All right? And now, we just want to combine like terms. So I'm going to combine those ones. I'm going to combine those ones. And I'm going to combine those. Okay? So 3x and a negative 16, or 3x squared and a negative 16x squared is a negative 13x squared. All right, so cross them out when you're done. All right, 6x and a 28x is a positive 34x. And a negative 9 minus negative 20 is minus negative 29. And I'm hoping to see that next door. Is that what we see? Oh yeah, baby. There it is. Number 2. Okay? So there's our answer to number 9. And finally, come to the end of day 2, number 10. All right. It's the moment you guys have all been waiting for. So what it's saying is, all right, it's basically kind of like another equivalent problem, if you will. Okay? This trinomial x squared minus 14x plus 49 can be expressed as, all right, so a couple tricks you could do. Plug that right into your y equals. Okay, y equals x squared minus 14x plus 49. All right, and then plug each one of these 4 things in and check your x and y values. If they match up, then you know that those 2 things are equal. Okay, if you want to do it the chintzy way, right? If you want to do it the algebraic way, which is encouraged, okay, what you want to look at is you want to try to factor this expression right here. So we want to look at the factors of 49. All right, so 7 times 7. All right, what's also significant about 49? It's one of our perfect squares. Okay, 7 times 7, and I think that's it. Can't do it. Oh, we can got 49 times 1. Can't forget that. Okay, that is it. So which means, all right, our numbers that we're going to have to use is 7 and 7. But if you notice, okay, we have a positive 49 and negative 14. So when we add 7 and 7 together, they need to be negative, but when we multiply those 2 numbers together, we need a positive 49. So both of these have to be negative. So it's going to be x minus 7 and x minus 7. Okay, well, I'm looking next door, and I guess we can definitely cross out this one, but I'm not seeing it. And this one's definitely wrong, right? Because we have an x minus 7, x minus 7. So which one of these could it be? Well, if you think about it, and if you haven't thought about it already, we have 2 of these, which means x minus 7 is getting multiplied to itself twice, which means x minus 7, we can say also x minus 7 is being squared. So this is our expression right here, because don't forget, x squared is just equal to x times x. So in this case, x minus 7 squared is equal to x minus 7 times x minus 7. Okay? And that is the end of number 10. And that is the end of day 2. All right, so be expecting these things to be emailed to you as far as the answer key goes. All right, and be expecting this video, well, if you're already watching,